Welcome back to the Pilot Forge. Today is a special session because we'll be taking a look at principles of flight, where we will take a look at takeoff and climb, and we will also see the demonstration on the sim. Starting with takeoff, here I have a diagram drawn up of what a takeoff looks like. So, lined up and ready, rolling, rotating, climbing. Now, the most important point over here is this formula. Lift is directly proportional to angle of attack and airspeed, because this lift formula is the reason why we are able to take off. How? We begin with lining up, we start rolling. As we gain speed, we reach rotating speed where we rotate and then set into the climb. So let's take a look at what the forces look like and how we actually end up in the climb. Okay. Number one, line up. Lift is 0 because angle of attack is 0 and airspeed is 0. Now I've got these in parentheses for a simple reason. I'll tell you why. At line up, your aircraft is not moving. Okay, therefore airspeed is 0. But there can also be a situation where the wind is strong enough that it can create a positive airspeed reading. Alright, angle of attack is 0. So in this situation, what you need to remember is that the way the wing is attached to the aircraft, it creates a slight positive angle of incidence. Now this positive angle of incidence also helps with the angle of attack. But since it is not moving, airspeed is registering as 0, therefore angle of attack also is 0. When the wind that is interacting with the aeroplane is strong enough, the angle of attack also becomes effective. The next thing we'll take a look at is the takeoff roll here. In the takeoff roll, the lift is now starting to increase. Why? Because airspeed has now increased. The aircraft is accelerating. The wind flowing over the wing is registering and the angle of attack is now becoming effective. Therefore, lift is being generated. In the third position, which is the rotate, the airspeed has reached the rotating airspeed, which is around 55 knots for majority of the aircraft. The angle of attack has become effective enough that the lift being generated is sufficient enough to lift the aircraft off the ground. Therefore, significantly enough lift is being generated so that the aircraft can actually lift off the ground. So, at this position, the aircraft has enough lift being generated by the wings and being helped by the propeller, creating thrust that it actually is capable of rotating and then climbing out. Alright, this transition to the climb, rotation, is quite important. I'll tell you in a couple of minutes why. Now, in the climb, what ends up happening is that you climb at a particular airspeed. Alright, this airspeed is sufficient enough. It stays constant. Angle of attack also stays constant because the relative airflow meets the aircraft at a particular angle. It doesn't change. So, what ends up helping us in the climb? It's only excess thrust. But we will take a look at it when we cover climbing. Let's finish the rest of it first. So, let's take a look at some points to remember for the takeoff. The first one, maintain runway centerline, select a point and keep transferring. Now, what I want to bring your attention to is the taxiing briefing. Okay, in that, when we wanted to taxi from one place to another, I spoke to you very specifically about selecting a reference point and then aligning your nose using the rudder as you keep on taxiing towards the particular reference point. For a takeoff, the taxi is going to be accelerated, meaning that you're going to accelerate your aircraft until you reach the point of rotation. So that reference point is going to approach you really quickly. So when you see your aircraft approaching the reference point from far away, you need to keep transferring it further and further away so you have a reference point that allows you to maintain that runway centerline, especially as you rotate and start climbing out, where that reference point is still on the ground and you might not be able to see it. In that case, you might have to transfer that reference point to the topmost point of your direction indicator. Now, I know it's a little bit confusing, but I'll show you what it looks like on the sim also. Alright. At rotation, now this is where a lot of students and a lot of instructors, I'm very sorry to say so, make a mistake. Now, what happens is, rotation is the action you give inside the aircraft. Assuming that this is your control column, what you do is you give it a little bit of an input. Then the tail moves and you have to wait for the air moving along the tail to create a reaction force. You don't peel the aircraft off the runway. It's not a banana skin, okay? It's just an aircraft. You have to give it the input, which is control column back, as much as is required, usually about 2 or 3 inches. And then you wait for the aircraft to respond. It'll respond how? It'll respond by gently raising the nose, where you will need to stop it at a particular attitude. Once the attitude is set, The excess thrust takes over and the aircraft then continues climbing. Now lastly, in the climb, keep your eyes forward. There is an unfortunate tendency I have seen where some people, after the liftoff and the initial part of the climb, somewhere about here, they tend to look back. The direction in which you are flying is there. If you look back, the only thing you're going to see is your tail, maybe the back seats too, which is not useful. You need to see where you're going. Keep your eyes forward. Alright? In some dangerous cases, you might also end up getting vertigo. Vertigo like spins in your head. So, instead of looking back, use your direction indicator to maintain your track. What is your track? That is the extension of your runway centerline, which you have been transferring by selecting a point further and further away in the distance. Monitor your temperatures and pressures and your aircraft performance. In case any of these are not in the standard range, you might need to carry out an emergency landing. Alright. And lastly, most importantly, and it's going to be the basis of all your flying, aviate, navigate, and only then communicate. Okay, so this is how we do a takeoff. Right now, at the current position, we are lined up. At the line-up position, there is no forward speed, although the engine is on. Here, look, this is where the engine is shown to be on. There is no real airspeed, therefore the wings are not generating any lift. Okay, therefore we are not flying. Okay, now there's something I wanted to point out about how looking back in the aircraft at liftoff and takeoff is not going to be useful. Let me show you why. Okay, this is the cockpit. Take a look at the back. There's literally nothing that is visible. Okay, that's a tiny window. It doesn't show you perspective. It doesn't give you a lot of information. Therefore, looking back is only going to end up showing you the passengers sitting in the back side or the passenger seats in the back. Right. Now, therefore, we select reference points as far away as possible. In this case, see that tiny tree right at the end? We want that tree to the right of our screw. Alright. As we rotate and we keep closing in on that tree, we will have to move that reference point further and further away. Now, instead of using some imaginary reference point, especially if you are flying over an ocean where it becomes difficult to do so, what we can do is this. See that? That is the direction indicator or the directional gyro. See that blue bug? That's called the heading bug. That's selected by this, and when you press it, it aligns with your current heading. This heading also coincides with your runway direction, which is 14. Okay, 140, 141, 143, it's all on the aerodrome plate. As you rotate, you want to ensure that it stays in the center. After rotation, as you start climbing at whatever speed, you want to make sure that this white marker sits exactly in the center of this blue bug. Okay, let me show you what this blue bug looks like. See that? That's the blue bug, and it needs to sit in the center of that white marker. That tells you that you are flying along the heading in zero wind conditions. On the left over here, you have the 4 speeds. Rotate 55 knots, Vx, which is your angle of climb, best angle of climb speed, 62 knots, glide speed, 68 knots, and Vy, your best rate of climb, 74 knots. Now, I'll show you the takeoff, then I'll show you what the climb looks like. Alright, so now let's begin our takeoff roll. I am going to use partial power so that you can see how the aircraft accelerates and how the controls become effective. Now, the way we look at the effectiveness of the controls is by using this particular dashboard's gap with the horizon. Alright, so when you pull the control column back, this gap becomes lesser. When you push the control column forward, this gap becomes wider. Alright, that tells you that the controls have become effective. Now, let's begin. Okay, releasing our parking brake. There you go. Look, aircraft is now moving. You can see it moving. And we may use the reference point that we selected before to maintain our runway centerline. As the aircraft accelerates, you can see that the controls have become effective. See how the nose pitches down, nose pitches up. Okay, this tells me that the controls are now effective. Let's go through to full power. Here we are coming up close to the rotation speed, 49, 50, 55. Gently raise the nose to the horizon. Here we go. See how the nose has risen up, and now the aircraft is going to climb. That's how you do a takeoff. Okay. Now, to remember that the reference point is now going to go under your aircraft, therefore we have to use the heading bug. Now, the heading bug is over here. See how it is being maintained. If the aircraft is drifting away from the heading bug, we make the corrections. Roll and yaw to maintain the heading bug. Alright. Now, this is how you do a takeoff. Once you've taken off, trim your aircraft out, and that is it. There you go. This will help us maintain the chosen speed. Now, what I want to bring your attention to is these things. First of all, we are about 75 to 80 knots. This is what the cruise climb looks like. Our nose is pitched up a little bit over 10 degrees, which is exactly what we want. And we can see that for the particular nose attitude and airspeed, we are climbing at about 850 feet per minute indicated. All right. Now, we've drifted a little bit off the runway centerline. We've come to the left. We need to make a correction to the right and go back to the runway centerline. All right. So these are things that we will do once we unpause the aircraft. All right, here we go. We've got the nose pitch set at 10 degrees. Aircraft is accelerating and we're maintaining about 800 feet a minute on the required runway centerline. All right. This is how you do a takeoff. Now, obviously, you're not going to be able to maintain runway center lines extremely accurately. That job can be done only by the autopilot. But that does not stop you from making corrections as and when it is required. So never hesitate from making any corrections you require, all right? That is essentially the crux of flying, bringing the aircraft to perform as you require it to.